Numerical Series 5. A certain amount of an ideal gas initially at a pressure P1 and temperature T1. First, it undergoes a constant pressure process 1 to 2 such that T2 equal to 3T1 by 4. Then it undergoes a constant volume process 2 to 3 such that T3 equal to T1 by 2. The ratio of the final volume to the initial volume of the ideal gas is, so the options are 0.25, 0.75, 1.0 and 1.5. So before we solve the given numerical, let's briefly understand the problem statement. So let us consider the coordinate diagram. We consider pressure along y-axis and volume along x-axis. So let us consider this is the state 1, or you can say the initial state of an ideal gas. It undergoes a constant pressure process, that is process 1 to 2. So here we consider this is a constant pressure process and this is process 1 to 2. So this is state 1 and this is state 2. So here in the quotient is mentioned that T2 equal to 3T1 by 4. So let us consider this as data given in the question. That is T2 equal to 3T1 by 4. Next, it is mentioned that the ideal gas at state 2 further undergoes a constant volume process, that is 2 to 3. So here we consider constant volume process, that is 2 to 3. So as this is a constant volume process, so here we can say that V2 equal to V3. Similarly, as process 1 to 2 is a constant pressure process, so here we mentioned that P2 is equal to P1. So just consider this for the information. Next data is mentioned here, that is T3 is equal to T1 by T2. Now here in this question we have to calculate the ratio of the final volume to the initial volume. So here it is clearly visible from this coordinate diagram that this state 3 is a final state and state 1 is initial state. So we can say that this V3 is the final volume. So V3 is final volume and V1 as initial volume. So here in this question we have to calculate the ratio of final volume to the initial volume, that is equal to V3 by V1. So this we have to find out. So here, as this is a case of ideal gas as per the question, so this is a case of an ideal gas, and the process 1 to 2, the process 1 to 2 is a constant pressure process, process 1 to 2 is a constant pressure process. So we can use the law, that is Charles' law, and this law is applicable to the ideal gas. So according to this Charles' law, volume is proportional to temperature at constant pressure. So this is a constant pressure process, and according to this law, volume is proportional to temperature. So here, for process 1 to 2, we use this relation T2 equal to 3 T1 by 4. 3 T1 by 4. So here we consider T2 equal to 3 T1 by 4. So simply if we rearrange this expression, this becomes T2 by T1 equal to 3 by 4. But as we are going to use the Charles' law, so we can say that V2 by V1 is equal to T2 by T1. So we can say that V2 by V1 is equal to 3 by 4. So this we consider as equation 1. So this is equation 1. Next, we consider the process 2 to 3. So this is a constant volume process. So as this is a constant volume process, we consider V2 equal to V3, which already we discussed here. So it is mentioned V2 equal to V3. So if we consider the equation 1, and let us consider this as equation 2. So if you consider equation 1, here in place of V2, we substitute V3. So let us consider V2 by V1 is equal to V3 by V1. So this must be equal to 3 by 4, and we can say that V3 by V1, that is equal to 0.75. So this is the final answer for the given question. So here we can say that the option B is the right answer for the given question. Thanks for watching. See you in the next video.